My name is Flash Isaac, and I'm a teacher from the future. When I told you that we have 7 main fundamental quantities. Any other quantities in physics apart from these are derived. Example: force, acceleration, momentum, velocity. All these are derived quantities. To get the dimension of derived quantities or their formulas, you need to know the definitions and what they are made up of. If I say, what is force? Force. You tell me that force is mass times acceleration. If I say, what is velocity? You tell me displacement over time. When you differentiate displacement, you get as a velocity. Now, what is displacement? Displacement speaks of distance, the ground covered by an object, like the difference between the starting point of an object to the ending point of an object. That is displacement, the distance covered in a specified direction. And talking about distance, distance speaks of length. Distance, space, length, that is about length, which means this is like saying length over time. What is length? Fundamental quantity. What is time? Fundamental quantity. What is the dimension for length? L. What is the dimension for time? T. So the dimension for velocity is L over T, which is the same thing as L divided by T, which is the same thing as L T raised to the power of minus 1. If I say 2 over T, division, to change this or to bring this up, it is the same thing as saying 2 T raised to the power of minus 1. 2 over T squared is the same thing as 2 T raised to the power of minus 2. So when you bring denominator up, it becomes negative. So talking about the concept of dimension, that is the dimension for velocity. Dimension for temperature is K, electric current is A, amp, luminous intensity CD, that's candela, is the dimension, and amount of substance is MOL. Once you get definitions, you simplify the definition, let them be in fundamental quantities, put the dimension of each of the fundamental quantities, you get an answer. So from now, we shall be solving questions under physical quantities to cover all these aspects, and we will explain so that you get the details. No stone is supposed to be left unturned. Which of the following dimensions represents impulse? Impulse. What is impulse? Impulse is change in momentum. Change in momentum is impulse. And what is change in momentum? Change in momentum is force times time. From Newton's second law of motion, the rate of change of momentum of a body is proportional to the force applied. And change in momentum is final momentum minus initial momentum over time. That is change in momentum. mv is final momentum, mu is initial momentum. If I say you've changed, it simply means the new you minus the old you, or compared to the old you, over the time period. So you change over time. Since mass is the same everywhere, it is the quantity of matter in the body. It doesn't change, although weight changes up and down. We say force is mv minus u over time. mv minus u over time. Now, what is final velocity minus initial velocity over time? Or what is change in velocity over time? Change in velocity over time is acceleration, which means force is proportional to ma. And in this thing, we are taking the constant to be 1. So equals k, k is 1. From here, force is equals m over t, and force is equals ma. So this is where we derived force is equals ma form, which we use throughout physics. This is by the wayside. Now from here, when you cross multiply, force times time is equals mv minus u. Here is change in momentum, which is final momentum minus initial momentum. Change in momentum is equals force times time. So this force times time is referred to as impulse. Impulse is usually defined as a large force acting over a very, very short period of time. So add this to your dictionary. Impulse is force times time, which means that force is mass times acceleration. So this is mass times acceleration times time. This is impulse. Now we try to change everything or to make everything become fundamental quantities so that we can use these units. Mass is fundamental, time is fundamental, but acceleration isn't. We break down. Impulse is mass times acceleration is change in velocity over time or velocity over time. So v over t times t. You look again, velocity is a derived quantity. It's not among this guy. So why do we make it among this guy? We break velocity down. Velocity is displacement over time. So this is m times displacement. You can say distance. Displacement is distance. You put it as s over time. This displacement over time is only for velocity. This time is here, so it remains times t. So everything here are fundamental because mass, distance, which is displacement, length, which is distance, which is length, time t, time t, time t. We simplify m times s over t divided by t. This is the same thing as this. Now let's change this division to multiplication. We will therefore have s over t times 1 over t. When you change division to multiplication, what is in the other part will invert, which means if I say s over t divided by 1 over t, if you change this to multiplication, it will be s over t times t over 1. So this is s times 1 is s, t times t is t squared. This is s over t squared. If you have any way to solve it, you get that. So s, that is distance over time squared times time. What is the dimension of mass? M times s is distance, which is length. So the dimension for length or distance is L over t is time. The dimension for time is capital T, time squared times time. This is simply m L t, m times L times t over time squared. This is equals m L. We have one time at the top, 2 at the bottom. So 1 cancels 1 from here. We are left with only 1 time. And remember what we learned. Once you have something at the bottom or t at the bottom, bringing it up, it becomes raised to the power of minus 1. So this is ml t raised to the power of minus 1. So that is kilogram meter per second. You see, from dimension, you arrive at units of quantities. So the units of impulse is kilogram, length is meter per second, kilogram meter per second. So this is the dimension, this is the unit. Let's see the option. Option B is the correct option, as you can see. Ladies and gentlemen, let's look at this. It says the values of S, Y, and Z respectively in the expression M, S, L, Y, and T raised to the power of Z for the universal gravitational constant, big G, is dash. It means the big G has mass, it has length, and it has time. So what is the value of the mass? What is the value of, or the power of the length? And what is the power of time? According to Isaac Newton, people called Isaac are usually intelligent. Yeah. Isaac Newton says that everything in the universe, or the bodies in the universe, they are attracted to each other by a force. And this force is proportional to the sum of their masses, to the product of their masses, and is inversely proportional to the square of their distance apart. Force is proportional to mass times mass over distance squared. Or you can say big M and small m. Big M and small m. Or M1 and M2. If you have bodies, two bodies, they are attracted to each other by a force that is proportional to the product of their masses. You multiply their masses and you divide by the square of their distance of separation. In mass or in variation, we don't solve with proportionality sign. We solve with equality sign or equal to. And anytime you have proportionality sign, when you convert to equality sign, you get equals k, where k is constant. In this our case, the constant or k is this big G, which is gravitational constant. So F is equals big G, big M, small m, or M1, M2 over rho squared. But we are looking for gravitational constant to be subject formula. This is what we are looking for, big G. We make it subject formula. This is the same thing as over 1. When you cross multiply, you have F times rho squared. F rho squared is equals G M M. To make G subject formula, we divide both sides by M M. So here M M, here M M. M M cancels M M. So G is equals F rho squared over M M. So G is equals F rho squared over M M. So back to business. What mass times acceleration is velocity over time. M times velocity is displacement over time, which is this, everything here is distance over time square, which is M L t raised to the power of minus 2. So I will actually advise you, this is the dimension for force. If you can even cram or know the dimension for force to be M L t raised to the power of minus 2, then you know the dimension for velocity. Velocity is displacement over time, that is L t raised to the power of minus 1. If you know this and this, many formulas or many of these quantities, they have force and they have velocity in them. So they have acceleration in them. So if you know the dimension for force, dimension for velocity, dimension for acceleration. Okay, let me just do dimension for acceleration. Acceleration is velocity over time. Velocity is displacement over time. Then displacement over time over time. This is velocity, this is time. This is the same thing as displacement over time squared. S over t divided by t is s over t squared. The dimension for force is mlt raised to the power of minus 2. The difference between dimension for force and acceleration is m. Acceleration doesn't have m, force has m. Knowing all these three, you'll be able to do almost any dimension because other quantity, they have these ones inside of them. So force is equals m l t raised to the power of minus 2. Radius is distance. Distance. So what is distance? Distance is length. That is L squared over mass is m. Another mass m. M times m. M squared. So from here, 1m, we cancel 1m from here. We are left with m here. We have L here and L. L times L is L raised to the power of 3. So this is L raised to the power of 3 T raised to the power of minus 2 over M. If this M goes up, it becomes negative. And in dimension, M should come first. So this is M raised to the power of minus 1, L raised to the power of 3, T raised to the power of minus 2. So which means here S is minus 1, Y is 3, Z is minus 2. So let's take a look at them. Minus 1, 3, and minus 2. Option B is the correct option. The correct unit of energy density is dash. What is energy density? Energy density is energy over volume. Mass density is mass over volume, or density is mass over volume, because we are talking about mass and volume. For energy, it is energy over volume. And what is energy? Energy is ability or capacity to do work. You see, work and energy. So you can get energy to be force times distance. This is force times distance. And volume is area times length, or force times distance over length times length times length. When you multiply length 3 times, or 3 lengths multiplied, will give you volume. From here, we know that force is mL T raised to the power of minus 2. Distance is the same thing as length. So the unit of distance is L over L times L times L. One L cancels one L here. Another L cancels another L. Mind you, the reason we are able to cancel is that what is separating everything here is times. What is separating everything here is times. If here were to be plus and here were to be plus, you dare not say that L cancels L. It is forbidden. If here were to be minus, then here times, here times, you dare not say that L cancels L. You dare not say it. It is forbidden. So we are able to say this cancels this because everything here, they are joined by multiplication. This is joined by multiplication. If this were to be like this, you can say L cancels one L because everything here, they are joined by multiplication. This is M times L times T raised to the power of minus 2. So what was here? L. This becomes M T raised to the power of minus 2 over L. This is M L raised to the power of minus 1 T raised to the power of minus 2. This is simply M is mass, kilogram. Length is in meter, so kilogram per meter, which is meter raised to the power of minus 1. Time is second, second raised to the power of minus 2. So from dimension, we've gotten unit, kilogram per meter per second squared, as seen in option B. And this is the dimension for pressure is equivalent to dash. Pressure is force over area. Force is mL T raised to the power of minus 2. Area is L squared. So 1L cancels the 1L from bottom. We are left with 1L at the bottom to give you mL raised to the power of minus 1 T raised to the power of minus 2. As seen in option A is the dimension for pressure. Which of these units is derived? You look at meter squared. Which one is not here? Coulomb is not here, so it is derived. Kelvin is not derived, it is fundamental. Kelvin, temperature. Ampere is unit of current, and current is a fundamental unit. Mole is a unit for amount of substance, and amount of substance is fundamental. But Coulomb, the most precise of the following set of observation is dash. I will give you this to do, not assignment. To look for the most precise out of the options, in option A, check the biggest value, check the smallest value, subtract. Option B, check the biggest number, check the smallest number, subtract them. Option C, check the biggest number, check the smallest number, subtract. Option D, check the biggest number, check the smallest number, subtract. The one that will give you the smallest answer is the most precise. So that is option C being the correct option. The dimensions of electromotive force are dash. Electromotive force is simply the energy provided by a battery to 1 unit of or 1 coulomb of charge passing through it. When current is not flowing, EMF is equals terminal potential, is equals voltage when no current flows. In simple term or simpler term, EMF is work done over charge. That is electromotive force, work done over charge. And what is charge? Charge is current times time. Current times time is charge. Charge is a derived quantity. Work done is a derived quantity. And now we have a formula update or dimension update. The dimension for electric current is ampere or I. You can use either A or I. Take note of that. If you see questions where you see I instead of A, know that we are still talking about current. And what is the rule? Convert all the derived quantities to fundamental quantities. Simplify. Work done is force times distance. And charge is current times time. Current times time. That is charge. Q is equals IT in physics. Q is equals IT in physics. Force is MLT raised to the power of minus 2 times distance is length L over I is current. So current is either I or A. So let's say A times T is time. This will give you M L squared T raised to the power of minus 3. Minus 2 here, this one goes up to become another minus 1. So everything becomes minus 3 times A raised to the power of minus 1. This goes up to become minus 1. This goes up to become minus 1. Multiplying everything, you get this. So this is the same thing as 1. You therefore get M1 L raised to the power of 2 T raised to the power of minus 3. Then this is A raised to the power of minus 1. If we decide to change A to I, which both are correct, we'll have I raised to the power of minus 1. This is the dimension for electromotive force. Once you know the definition of the quantity, you should be able to find the dimension. A is the correct option. What is the dimension for surface tension? Surface tension is force per unit length. Force over length. Force is ml T raised to the power of minus 2. Length is L. So this divided by L goes. You are left with m T raised to the power of minus 2. So option B is the dimension for surface tension. A solid cylinder of radius 3 cm has a total surface area of 36 pi cm squared. Find its height. The total surface area of a cylinder TSA is equals 2 pi r square plus 2 pi ROH. 2 pi r square plus 2 pi ROH. That is the total surface area of a cylinder. Now this is the height. We are given the total surface area to be 36 pi cm squared. 36 pi cm squared. So 36 pi is equals 2 pi radius times 3 squared plus 2 pi times 3 times h. So that is basically substituting. If we decide to factorize out pi, we have 36. This one is gone. you can support to buy marker. 36 pi is equals, there is pi here, there is pi here. From here, 3 square, 3 times 3, is it 9? Yes. 9 times 2, is it 18? Yes. So this is 18 pi plus 3 times 2, 6. 6 pi h. We can bring out pi to have 36 pi is equals pi 18 plus 6 h. If we divide here by pi and we divide everything here by pi, what is holding this and everything here is multiplication. So pi cannot cancel anything inside here, but it can cancel anything outside because everything here is 1 bracket, here is 1, and this is times. This cancels this cancels this. So 36 is equals 18 plus 6h. 36 minus 18 is equals 6h. H is equals 36 minus 18 over 6. That is your value of height. According to me, it is 3 cm. If you get something else, you let me know, then we'll negotiate it. Which of these will give a fundamental quantity? In this type of question, you start from the known to unknown. Option A, mass times acceleration. Mass times acceleration, that is force. Yes. So force is derived quantity. You go to another simple one. Option D says force over impulse. Force is F, impulse is force times time. Force divided by force times time. Force cancels force. We are left with 1 over time. That is fundamental quantity. So option D will give us fundamental quantity. Starting from the simple ones to difficult ones, no need to check B and C. Since D is fundamental, the rest can go to wherever they want to go to. So we've gotten our answer to be option D. The unit of momentum is dash. Momentum is mass times velocity. Velocity is Lt raised to the power of 1. Mass is kilogram. Therefore, kilogram meter per second is the unit of momentum. And kilogram meter per second is the same thing as Newton seconds. Newton is kilogram meter per second square. Kilogram meter per second square times seconds. That will give you kilogram meter per second, which means kilogram meter per second is the same thing as Newton times second. Option B is the correct option. In alternating current theory, the units of impedance, voltage, and resonance frequency are dash. Impedance is opposition to flow of current offered by resistors, capacitors, and inductors. In your DC circuit, you deal with only resistors as opposition to the flow of current. By the time you advance to AC circuits, you will see resistors, inductors, and capacitors. They are all offering opposition to the flow of current. In that case, we refer to them as reactance. So the opposition by capacitors and inductors is reactance. When resistor, capacitor, and inductor merge to offer opposition, that total opposition is referred to as impedance. So it is measured in ohms, just like resistance. Voltage is measured in volts, and frequency is measured in hertz, making option B the correct option. Thanks for watching your one and only teacher from the future. I hope you found this class interesting. Feel free to check out the playlist for more amazing videos, and don't fail to install the Flash Learners application right now for notes, videos, and questions to meet all your needs. Subscribe to this channel so you don't miss out any of my sweet videos. See you in the next episode. Don't forget to tell everyone around about the Flash Learners. Bye.